Hello, good morning. My name is Victor, and I'm going to be your anchor for the Cisco Cybersecurity Operations Associate, also known as the Cisco CyberOps. So it's a 28 module series that covers tier one level skills and knowledge with respect to someone that wants to be in a SOC, a Security Operations Center, or for a small organization, you want to be able to be a defender, protect the IT infrastructure. Okay, so we have 8 modules done. So we're in module 9, the transport layer. So the question is, what's the transport layer? So I think that's the fourth layer in your OSI model. So you have the physical data network transport session, presentation, and application layers. We looked at that in the previous module before this. And we are at the fourth layer. There are some very important layers you want to understand. You want to understand the physical layer. You want to understand the data link layer where you have the switch. Switch is a layer 2 device. Router is a layer 3 device. Now, what's the goal? I want to be able to explain these transport layer protocols and see how they support communications, communication sessions, and how do they establish reliable communication. Now, you have the OSI model, which has 7 layers merged into what we call the TCP/IP model. So the transport layer is what we're looking at. You have network access, which covers physical data and network layer. So they are all compressed to become the network access. And of course, we are concerned about the transport layer. So what does the transport layer do for us? It ensures communication. And we have about 2 types, the TCP and the UDP, Transmission Control Protocol and user data ground protocol. And the thing is that these 2 types are applied in different technologies with respect to communication. Now, what's the goal? What's the responsibility for the transport layer? Responsibility of the transport layer is to maintain and track different types of connection you're going to be having within your PC or within your device. Most networks have limitation on the amount of data that can be included on the single packet. Data must be divided into manageable pieces. So that's what you call data segmentation, right? Or sequencing. So each data, depending on the quality of service to be ensured, needs to be broken down into fragments for data fragmentation. Now, each fragment will be given a sequence number and they will now be queued for the purpose of creating a reliable communication. Now, that's what we call segmentation of data. Then, when data is being segmented, at the end of the day, it's going to be reassembled at the other end. So, if I'm sending $1 million to you, so and we have a limit with respect to payments from my bank or from PayPal or from wherever, and I'm told that I can only send $200 million, or I can only send $200,000 per month. So what is going to happen is I'm going to send $200,000 for this month, another $200,000 for the next month. Then it's going to take me 5 months to send $1 million. So at the other end of the communication, my account officer or my recipient is going to reassemble the whole 5 tranches of $200,000 and be able to have the whole data, the whole cache. Whereas at my own end, I have to segment it, I have to put it in small pieces. So communication is always done like that also. It is the transport layer responsibility to divide the application data into appropriately sized blocks. Depending on the transport layer protocol used, the transport layer blocks are called either segments or datagrams. Don't forget about MoneyGram. Yes. So just blocks of packets. So this is what it looks like. So if I'm to download any of these things, or if anything is going to flow through to my network, it's going to come in different segments. Then there's what we call header information, right? I think what we did, I think it's digital forensics. In digital forensics, when we ran that course, we said that one of the ways to understand the source of data, to understand the purpose of data, is to look at the headers, right? In web, in network, in cloud, in several areas in tech. The of the data contains what we call metadata. So we say metadata is data that explains data or data that gives you details about another type of data. So the header is very information. If you go to your email, you see to, you see from, you see subject. This is like the header. Same thing when you're sending a letter, you put the address of the letter, you put all the things. Even inside the content of the letter, you put your own address, you put the address of your recipient, you put your phone number. So that portion is the header. So in transmitting blocks of data across our network, things are also done that way. So something goes ahead as the header of the data. Don't forget, companies also have what we call the letterhead. So the letterhead is that guide that shows summary of what the data is about and where it's coming from. So when we see the letterhead, we can tell the name of the company, the address, the phone number, what they do, and whatever. Then before we can start looking at the content of the letter. So the transport layer also add header information into several fields to each block of data. It's just for easy identification. Things like IP address, who owns this stuff, where is it coming from, port number. Imagine if you have a message and it doesn't have the source IP address and the destination IP address. We talked about that in the previous model. So if it doesn't have the destination IP address or the source IP address, the means it's going to be leaving our network, but it's going to be heading nowhere because it doesn't have an address of the address of the recipient. So that's why header information is very important with respect to the transport layer. Yes, identify applications. So the transport layer helps us to identify applications. Now you have different applications and their port number. If I were you, I would take my time and get out 20, 30 port numbers, their names, uses, and their applications, right? So if I see 80, for instance, I know it is HTTP, I know it's being used by web pages and anything that connects to the internet. If I see 110, I know is this should be SMTP, that's Simple Mail Transfer Protocol. Then it's on electronic, it can be applied to electronic mail. Same thing with internet chat for port 531. Conversation multiplexing. So how can we do more than one thing at a time? Sending some type of data across a network as one complete communication stream can consume a lot of bandwidth. If you do CCNA 3, I think there's a module called quality of service. So that's where you get to understand this thing in great detail. But meanwhile, you can understand multiplexing as saying, how can we segment our data and still run everything at the same time while checking for error to make sure that we don't have any clash or we don't have any issues transmit data. Else, that data is going to be dropped. So error checking can be performed on the data in the segment to determine if the segment was altered during transmission, right? So this is what you call multiplexing. Then this is what you call segmentation. So you break it down into piecemeal, then you run everything together, multiple all at a time, while ensuring that you don't have errors. Okay, now transport layer protocol. So this is very straightforward. You see the way this guy is. So this is my network access. So you have your three layers here: physical, data, network link, data layer, network layer. I mean, in these three layers, it's all compressed to become my network access. So I have my LAN connection and my what's it called? My WAN connection. I have my IP is divided into two types. Like I said, TCP, which we call the connection-based type of protocol, and user datagram protocol, the connection that it's not connection-based, right? So I don't have to create a three-way handshake before I can have connectivity. Question is that what are the applications that utilize this protocol? So we have TFTP, Trivial File Transfer Protocol, then domain name service. Domain name service also uses the TCP. You see this arrow coming here. It's used in by servers, either local servers or remote servers. Then for TCP, where I need to guarantee connection, I have FTP, HTTP, and SMTP. Okay, so so these are some of the characteristics that make TCP reliable. Not that UDP is not reliable, but we said that it has application in different areas like via voice over IP, like streaming, like when you need to move large streams of data, use user datagram protocol, because at sending those packets that they don't first create a connection before they start transmitting, right? Ehen. So, but its advantage is that you can move large data sets at a time. It's very fast, it's very swift compared to TCP/IP where you have to check every time you need to make a connection. Okay, so please log into your Cisco Learning Management System. There's a short video that explains the TCP uh, suite. Please, I think it should be 3 or 4 minutes. So log into your Cisco LMS and make sure you watch this. So the purpose of these videos is to concretize your learnings with respect to the Cisco management platform. So you should have access to the Cisco management platform. Then once you have access to that, you can use these materials as backup learnings to better you understand all of the content you have on the platform. TCP header, like I said earlier on, you're going to have quite some information. The sequence number, checksum, header length, window, urgent, destination port, source port. All of this information, we just need it. So that when this data is going from one point to the other, at the other receiving end, they could identify, is this for me, right? So these are the different header fields and the explanation of what they contain. Look at this very important one, checksum. A 16-bit field used for error checking of the segment header and data. So it doesn't just check only the header, it checks both the header and the data to ensure that there is no error. If there's error, the guy is responsible for dropping it. Look at this other important one, source port. Port can be 80, right? Port can be whatever. You have hundreds, if not thousands of ports. Destination port. If you use TCP view software, for instance, the TCP view software, I think it's one of the softwares you have within the sys internals tool. So you say sys, go online and say sys internals. Let me open this stuff a bit. Sys internals suite, right? So there you open up TCP view, right? Is it TCP view? Yes, TCP view. So with this tool, it's a small tool, I think less than an MB. If you open it and as you're working on your PC, you're going to be seeing all of the background communications that happen to your system. You're going to see source port, destination port, you're going to see sequence number, you're going to see um, I think that's a few things you're going to see. You're going to also see the application that is using this port. And aside the destination port and destination source port, you're going to see the source IP and destination IP. So it gives you an idea of how this communication is being done. Then the next protocol is the user datagram protocol. It's simpler. It does not provide reliability and flow control. So that's the difference between TCP/IP and or rather TCP and UDP. TCP provides reliability. It has to ensure, for instance, if I'm to collect, let's say, $1,000 from you. So the thing is that I will first need to make a connection with you. I will say, hello, good morning. Okay, my name is Victor. I need $1,000. Please, can you help me with it? So we have to have a connection, a conversation first before we can start transmitting. Okay, take $20 for now, take $100 for now, then take at the end of the day, I'll give you the entire. So I segment the money. At the end of the day, you have the $1,000. But for UDP, we're saying that once there is need to do that communication, you just start sending the $100, right? So that's why we say it does not provide reliability, as we cannot ascertain if this guy is going to get it or not, right? That's why if you want to make a phone call over IP, a voice over IP, you just pick the phone and you just call. So if you make it, fine. If you don't make it, but for a website have, if you want to browse, for instance, and get access to a website, you first have to establish connection with the server first. It's when you connect to the server first, then you can also start collecting data. But for user datagram protocol, we are saying that the connection is not done. The data just started being transmitted. Okay. Sender and the receiver UDP processes do not have to manage reliability and flow control. So that's why we call it a connectionless protocol, whereas TCP is a connection-based protocol, right? Okay, so please watch this short video on your Cisco LMS to grasp a lot more about some of the basics I've explained here. This is the header. These are the different header fields. Socket pair, of course, you have to have both sides, both from the receiver, sender, and the receiver. The source and destination ports are placed within the segment. The segments are then encapsulated within an IP address. When we say encapsulated, we are saying that if I'm going to send information to you, first I need my source IP. I need your own IP address. And I need your port number, my port number, sorry, and I need your port number. As I'm progressing, I'm going to now be going to the data link layer, my MAC address. So which MAC address am I on? I'll get the MAC address, right? As that is transmitting, depending, I will not get my ISP or whatever. It will carry information about my country. It will carry information about like that. So when it gets to that particular end, we can be able to, for instance, when we do forensics or when we're trying to analyze where this data is coming from and where it's going to, because the headers, they take all of those information, they encapsulate, and at the other end, they start doing what? They start de-encapsulating. So you start opening up, oh, it's from US. If it's from US, the next thing is from which state? It's from a particular state, like that, till you get to that particular ISP, get to that particular system, and get to your particular message. So that is called de-encapsulation. Okay, so this is it, a little bit more explained. So the MAC address, source, destination. So it just gathers all of this information and sends it across. Okay, so if it's on a server, same thing applies, right? Same thing applies. You can read this up. Same thing applies. Same thing applies. If it's client to server, same thing applies for TCP. So you see the source port I was talking about, see the destination port, see the source port, destination port. So if this guy should transmit it out to this guy, it needs with this guy's details, so I can send to the server. Server will now say, okay, who have these details? And I'll send it to this guy. Okay, so these are just explanatory. So this is what we call the three-way handshake. So the three-way handshake is normally you have quite a number of flags. Not all is covered here, but let me, I think, write them down for you a bit. Okay. So there are quite some flags you have. You have sync flag. You have sync flag. You have acknowledge flag. Let me make this smaller so that everything can enter into this stuff. Um, 0. I have sync. I have arc. I have reset. I have push. I have sync acknowledge, reset, push, urgent. I have sync acknowledge, reset. Okay, if I remember the rest, I'm going to let you know. But I think just about is covered here. Sorry. So okay, you have syncs, acknowledge, reset, push, urgent. So sync, for me to first initialize any communication, I have to use the sync command, right? Then at the other end, somebody is going to receive, somebody is going to accept. Then for reset, take for instance, if you want to browse, you want to use the internet, you're on your phone or you're on your PC on the network. What's going to happen is that before, why you open up your browser, you try to say Google or you try to say either CNN or Fox, depending on which is your favorite. What's going to happen is that your browser will start sending some trying to synchronize some sync packets to that particular server, that particular website you're trying to access. It do that most of the times, like two, three, four times, in order to get a reply. If it doesn't, each time is retrying, it's going to be resetting, right? And of course, push, when you're pushing data across your communication, then urgent, if you have quality of service implemented, where you're creating maybe on your router or any of your configurations on any of your firewalls or whatever, if you indicate quality of service, most Cisco routers and other network routers, they have those configurations. They'll tell you quality of service, which service do you want to have priority. You can say TCP, you can say HTTP, you can say HTTPS, you can decide any, you can even decide an application that you want to have higher priority. So even when the bandwidth is low, you can see that you have a higher priority given to. So that's a classical example of the application of urgent. The three-way handshake has sync, it has sync arc, then it has acknowledge. So this is it in full. I send the sync hello. You tell me, okay, I've received your hello. You say, okay, let's start communication on so and so so. Then before the information has start moving back and forth. So it's normally an arc. So you have that three-way handshake. So that was an example of what three-way handshake is about. Okay, so okay, another one is finish. Yes, I think that's the sixth one I'm aware of. Finished, finish. Uh, let me add it here. Finish. Right. So these are some of the flags you have: sync, acknowledge, reset, push, urgent, finish. So finish comes up at the end of the communication, right? This is it. To close the connection, the finish control flag must be sent in the segment header. So once the other party sees that, know that, oh, we're done with our communication. Okay, so explanation of how it can be terminated using the finish command. So this is the explanation of the three-way handshake I just did. Host, maintain, stick, track each data segment within a session, exchange information about the data that has been received. Then for a full duplex protocol, that's a two-way communication, the host performs three-way handshake. The functions of a three-way handshake is what? Establish that the destination device is present on the network. So it first establish that before sending anything, right? It verifies that, then informs the destination device that it intends to establish a communication on that port number. Like I said earlier, if I want to get $1,000 from you, I can't just say give me $10,000. That's like a user datagram protocol way of collecting money. But if you want to go through the TCP reliable way of collecting that money or taking that money or loaning that money, you say, hello, Mr. Maxwell. Okay, my name is Victor, and I have interest in taking a certified information system professional training because I've done more than 15 years in tech and I've done quite about 6 years in cybersecurity. and I qualify to take or retake or recertify my CISSP exam. That's my Certified Information System Security Professional certification. So please, I will need you to make an investment in me by donating or even loaning me $1,000. The exam is about $750, but I could use the remaining $150 to make preparation, or rather $250 to make preparations to get some more materials to enroll for maybe a short training and write the exam. At the end of the day, I'm going to be giving you return on investment of about $3,000 in the next 6 months, because I'm going to get maybe a job, I'm going to get a consultancy, or I'm going to get a freelance assignment. So you see, this is a more better way, because you want to gauge the other end is ready for you. Then once you receive a reply, then you can now start saying, okay, these are more details about the transaction. Or you can even say, okay, hello, my name is Victor. I'm a cybersecurity expert. I need to do this and whatever. Are you ready to invest in me? You're going to get returns on investment. Once the person says, yes, I'm available, then you now start sharing details about uh, that investment he's to do on you. So that's what we mean by it first intents, first checks if the other guy is ready, right? Like I explained with respect to your website through your browser. So these are the flags. So we have it here: urgent, acknowledge, push, reset, sync, finish. So please, there's a short video on the three-way handshake in your LMS. I would love you to watch this 6 minutes video. It's a very nice video. Watch it to better understand this training. Now there's a lab on Wireshark. You could try it out. Um, Captures data through, you just start browsing. After doing that, you start capturing through Wireshark. Then you can also view the packets using TCP dump. Reliability. So we said that TCP is reliable, is guaranteed because it's ordered. So these are the things that makes it reliable. Then you can also check up that video, see how sequence number and acknowledgement can aid reliability. Because if I have the sequence number and if anyone has a problem, I can easily drop, I can easily resend. Then data loss and retransmission, like I said. So TCP provides ways of you managing your segment losses by retransmitting the segment for the unacknowledged data, right? Take for instance, you're trying to browse and you have a website you visit because your connection was not so reliable, was not so strong, your ISP. At that moment, you are served with some parts of the web page, not everything. So because we're using TCP, you could do a refresh, right? And you can have only the part that was not delivered re-delivered to you, right? Okay, so you see, I'm sending this, but 3 and 4 failed, right? So from 5 to 10, it's what? When he's sending it again, from 5 to 10 is duplicate segment because 5 to 10 was received before now. So I only needed 3 and 4. This one that was cancelled, right? So that's the way it works. Here you have a short video to explain it in details, and these videos also short videos, they have some kind of simulation. Okay, still acknowledgement, Windows flow and acknowledgement, same thing. Maximize segment sizes, flow controls. How does it do all of that? Still same thing. How does it manage congestion? Where you have congestion within your network. Exploring Nmap. So Nmap, I'm sure you've used Nmap during your web security training. It's a very nice tool you can use to perform reconnaissance and vulnerability assessment. There's a few things that Nmap does for you. Plots. So this is Nmap. This is what it does for you. So one, It does, let me take this off. It does bold underline. So it does Nmap does OS fingerprinting, live ports, or I will call it open ports. That's rather more nice. Open ports, of course, closed ports. Let me reduce this also so I can write more. Open port, closed port, network topology. That's to say, map can plot how my network looks like, whether I'm running ball, star, or hybrid. The entire layout. So aside OS fingerprinting, what else does Nmap do for me? It does OS fingerprinting, open port, closed port, network topology, running services, um, network adapter details like make, MAC address, so make a model, make a model. So that's to say, if you allow somebody to come into your network and run Nmap too, you can just start a simple scan and to get all of this information about your network. You can also fingerprint device usernames, work groups. So there's a whole lot that Nmap can do. This is a little I can remember. So if you run Nmap as a tool on a network, you can grab all of this information with little or much. So this is the end of the Cisco Module 9 training. I'll see you in Module 10. Thank you very much.